There we go. Okay, so the try it now 4 says India had a population in 2008 of about 1.14 billion people. The population is growing by about 1.34% each year. If this trend continues, when will India's population reach 1.2 billion? Okay, let's see. What are the informations we have and what can we do with those informations? So we have right now 4. All right. So in 2008, 1.14 billion, and it's growing by 1.34% each year. And it wants us to find when will India's population, that means we are looking for M. Can you see that? If you just uh, if we can just eyeball what we are looking for, half of the job is actually done. So from this given informations and um, what the questioner wants us to do, we can clearly eyeball that we want to find n here, and we have one more information to use, that is our population will become 1.2 billion. Okay. Is there anyone in the waiting room? No. Perfect. Okay. All right. And the second question would be, how is this growing? Is this uh, linear growth? Is this an exponential growth? What should we do? Uh, or rather, how can we use these informations to solve this problem? Okay, so one thing we can clearly see that it's looking for the m. The next thing we need to understand, which model should we use? Is this the linear one or the exponential one? Anyone who can volunteer this answer? By just eyeballing, because you can't really visualize the graph, and the graph will not be given in each question. So by just eyeballing the informations, you need to understand which model we need to use and why. Anyone wants to have a go at this? Um, Azizi, are you here? Can you hear me? I hope I pronounced your name right. Azizi, can you hear me?
Is it exponential?
Okay, why do you think it's exponential? What made you think?
Um, I don't know. It was just a guess.
Okay, so can anyone tell me? Well, her answer is right. Definitely, it's exponential. But can anyone tell me why it should be exponential, and why? I mean, what made you think rather that it should be exponential? Because uh, oh, okay. So can you tell me, Azizi? Obviously, if I'm pronouncing your name right, can you tell me why this model should be the exponential one? Can you unmute yourself, or you can write in the chat section, whichever works for you. because in this particular topic, growth models, um, it's really important to see, or rather know, that which model it is and definitely why. No clue yet. So, okay, no problem. Okay, so let's just see why it should be exponential and not uh, linear. Okay, so for the linear model, what was the explicit format? So we had this P naught, PN. PN is the population after nth year or at the nth year. Okay, and excuse me. Then we have P naught plus ND, where N is the time duration and D is the rate, right? And D, this is just a quick reminder though, because we want to see the relation and the differences mostly, the similarities and dissimilarities, so that we can distinguish which is linear and which is exponential. Okay, so this would be the change in output, the change in input. So basically, the change in input would be in years. That means for a certain time duration, we'll have um, um, the change in input. That means, let's say, from 2000 and 2005. If we consider this time duration, the change in input would be this, the difference of that time duration. So, and the corresponding population, or whatever it is, whatever uh, the given information is, the corresponding values of this would be our change in outputs, right? Okay. Now, what happens if we have an exponential growth? So once again, it will be Pn, and then we'll have 1 plus r to the n, right, times p naught. Anyone? Any question up to this one? Because once again, we want to know the differences. Obviously, we want to know the similarities as well. It will be kind of related when we discuss these things. So that this is the formula, right? So first of all, oh sorry, I didn't mention it. It's R, which is the growth rate rather. It I shouldn't say the growth rate, because it could be the decay rate as well, depending on the sign of R. If R is positive, then it's growing exponentially. And if R is negative, then it's decaying. That means it's getting reduced exponentially, right? Okay. Now look at the given information. Oops, sorry. I should have written it just a little bit smaller. Now I need to scroll up and down. Anyway, so we have uh, the growth rate, which could be D, which could be R, but here we have only 1 year and only one population, so definitely it's P naught. We don't really have any other P's, right? We don't have any other year and any other information. Okay, so that means, excuse me, clearly I don't, I can't really find, I don't see any way to calculate D here. Okay, because for D, as I said, we'll have certain time duration for which we'll have a corresponding population as well, which we can use to find D. So this made me think that it has to be exponential. That's the most naive approach, of course, but that works. Okay, so now let's just start solving it. So it will be Pn equals to 1 plus r to the n p naught. Okay, what could be another thing that made me think uh, that it's exponential? So it has a growth rate of 1 point, whatever, what is it? Okay, 1.34, 1.34%. Okay, and for the exponential growth, r is actually presented in percent. So that's another thing you could say that could make you think that yeah, it should be exponential. Okay, all right. So our p naught, or we're looking for n rather. Pn is given, which is 1.2 billion. P naught is 1.14, and is it 1.14? Yeah. Okay, and R. Okay, what is R? Now this is since we have figured out that it should be exponential model. Now the next topic, or rather the next job in our hand, would be to put things into places. That means to know what is which information uh, signifies what, and if we need to transform it, if we need to make changes into it, we need to do that. So how can I plug in R? Should I straight away write 1 plus 1.34? What should you do? Anyone? What should you do? How can you plug in R? No one? Slightly.
Shouldn't
Yeah,
it be one? Shouldn't it be 1 plus 0.0114 because it needs to be a decimal instead of a percent?
exactly. That's really important. That's why I've asked. So if you have R, that means growth rate, given in percentage, you need to transform it. You need to rewrite it first in decimal. Sorry. Uh, you need to rewrite it in decimals. Oh no, I'm doing it again. Okay, so R is 1.34%, and if we transform it into decimals, we get 0.0134. Just dividing it by 100 because it's given in percentage. Okay, so now we can plug in R. So it would be 1 plus 0.0134. And of course, P naught is the initial population at the starting year, which is 1.14. So now we have the equation. We just need to solve it. So the first job was to find the model. Second job was to set up the equation by plugging in the values. And third is to solve using the techniques we have seen. Okay, now let's solve it. All right, so we are looking for, oops, sorry, it should be n here, exponential. Okay, we're looking for the n, this one, this n in red. So somehow or other, we need to isolate that. We need to isolate that term with n first, and then we'll isolate n completely. So if we want to isolate this term with n, what's the first thing we can do? What can you imagine by just eyeballing this?
Would you try to do it to the root of n?
Okay, so this is the nth power. So yeah, your idea is sort of right, that if we take nth root, but what that would do, that would actually cancel this n, because nth root is basically 1 over n. I mean, something to the power 1 over n. So if we take the nth root on both sides, obviously whatever we do, we need to do that on both sides. If we do that, that will actually cancel n on this term, and we'll have additional 1 over n here for these two terms. So this doesn't work.
Divide by 1.14.
Exactly, divide by 1.14, because I actually mentioned a word which is really crucial here, to isolate the term with n. That means we somehow or other we want to isolate this guy. Okay, so that means, in other words, if I rephrase it, we want to get rid of this additional term. So we can divide both sides by 1.14. So 1.2 divided by 1.14, which will give us 1.0134 to the n. Okay, and if I just rewrite this on this side, I'm just changing sides for this. So 1.12 divided by 1.2 rather, divided by 1.14 gives us 1.05. We can take up to 4 decimals at least. So 26 will do, I guess. Okay. Okay, now what's next? Again, we want to find n. So somehow, after a couple of steps, we need to have only isolated n on our left, or whichever side you want, doesn't matter. Generally, we tend to have this on our left. So somehow or other, by doing different things, we want to have this isolated n here. Now, what should we do next to do that? Who wants to um, volunteer this?
Would you take the log of 1.0526?
Okay, so you're saying I'll just take log on my right.
Yeah.
You're almost right, almost, yeah, very good. So whatever you do, you need to do that on both sides. So technically, you're almost right, but you need to do that on both sides, not on your right only. Okay, now the next question would be, why should we do that? Definitely we can take log on both sides, because this is an equation. This is an equation, and we can actually operate anything on both sides that will still keep our value intact for this equation. So we can definitely take logarithm on both sides. But why should we take that? The reason I'm doing this today is because this particular topic, growth model, is really easy if you just know the steps. But if you don't know at least one of the steps, then you are in trouble. So I think I need to spend more time uh, on doing the entire problem so that you can see what's going on here. Probably explaining the steps more and more. I mean, why this is happening, and then how is this happening. So my question would be, yeah, I'm completely, I completely agree rather with her that we should take log on both sides. But the question would be why? There should be a logic behind this, right?
Is it to get rid of the exponent of n?
And how can you do that? How can you get rid of that?
That's the part I'm not clear on.
Exactly. That's why I'm trying to do that. Okay, no problems. So if you remember, we know one property of logarithm, which is this, which looks like this. Doesn't matter, it has to be x and n always, but it is of the same format. So whenever you have a logarithm in front of exponential, you can write this exponent in front. That means we can write n times log of x. That's the property of logarithm. So the exponent, the power, comes in front when logarithm is operating on that. So clearly you can see, if we have an exponential, logarithm will help us to take this or to bring this in front, which will make our life really, really easy. Can you see that? That's the reason we'll take log on both sides, and we have already taken log on both sides. Now, using this very property, you can see the logarithm will come here, and we'll have 1.0134 equals to, obviously on our right, we don't have anything else, so it will remain as it is. Any question up to this? Take your time and just try to understand each step. I'm repeating myself, this is really, really easy, even easier than the topic logic, because in some of those you had to play with notations, and this could be sometimes tricky. But here everything is straightforward, but you need to know why and how everything is happening. So if you have any doubts, you can make things clear right now, right here, right now. And if you want me to rediscuss any of the steps right from the word go, I can do that for you. No questions?
I do, sorry.
Sure.
So basically the log just brings the n to the front, and that's the next step, is just putting it in front.
Sorry, would you please repeat it?
I was just saying that, like, basically what you're saying is that when we put log, it just brings the n in front, and
Right.
that's
Yeah.
the next step. Okay, thank you.
Okay, so now we are trying to isolate n, right? We want to have this n isolated and everything else on the other side. Now what's the next thing we should do? What's next?
Should we subtract log of 1.0134 from log of 1.0526?
Okay, very good point. You're almost right again, but not quite. So she said, we can we subtract? So the point is, this n is actually a product with this, working as a product with this, right?
Oh, okay. You divide it.
Exactly, very good. So we can divide this, and let's do it this way. So we can divide both sides by this. So let me show. So this will be divided by log of 1.0134 equals to log of 1.0526 divided by log of 1.0134. Again, whatever you do, you need to do that on both sides to keep your value intact, because this is an equation. Now, this will cancel each other, so we'll have n on our left. Finally, after several steps, you can see we have got rid of everything else and we have successfully isolated n. And now we can use our calculator to see what's the value of this, and this should be almost this should be our answer. We'll see, because we can we might need to round it depending on whether it's um, or rather which is the closest possible integer or whole number, okay, depending on whether it's more than 0.5 or less than that, after the decimal, of course. Okay, so log of 1.0526 divided by log of 1.0134, and it should give us 3.85. Up to 4 decimals it will be 1 2. All right, so the next question would be okay, look at the question first, whether it, yeah, I think it wants you to find the year when it will be year, right? Yeah, so as it's in year, so it's 3.8512 years. So what would be the closest whole number of this? We have 3.85 here. So after the decimal, we can see it's more than half, right? More than 0.5. Can you see that? It's more than 3.5, right? So what would be the closest? We are trying to round it, because it's the question actually wants us to find the year. For example, the initial year was given is 2008. So we want to write it in years. We can't really keep it in this format. We want to find the closest whole number, the nearest whole number, and then we can see which year it should be. So what it should be, or would it be 3 or 4?
4.
Yeah, because we know if it's more than 0.5, or even starting whether it's equal or more than 0.5, even if it was equal to 3.5, we would have written 4. So if it's equal, or let's say we have n greater or equal to some digit n.5, then we'll write n equals to the next integer, which is n plus 1. So it's more than 3.5, so we'll write n is approximately 4. So our initial year was 2008, so our answer would be the population will become 1.2 billion in 2012, because n is 4, right? Is it? Okay, it's whether it's the starting value or end value. Let me see it again. Why is that? Try it now question. Try it now for, okay. Okay, in 2008. All right. Oh, okay. So it's actually someone has entered the waiting room. Just give me a second. Okay, yeah. So it's the population in 2008, not at the end. So we can say 9, 10, 11, and okay. So should it be 2011 then? Because in 4 years, it will become 1.2 billion. Okay. Okay, so let me see why it's 2011. They're saying it's 2011, but it should be 2012. I'm wondering why. This could be a typo. Okay. Okay, who wants to have a go at this? Why this should be 2011 or why this should be 2012? Anyone has a logic behind this? I have my own, but I want to hear from you. Anyone? Just go for it, even if it's wrong.
I think it would be 2012 because we have the base year, but I don't think we count that as one of the 4 years.
Exactly, that's my point being, because this is P naught, right? This is for the n equals 0. So if n is 4, it should be 2012. I'm just wondering why they have given 2011 in the answer. When I was cross-checking it, it says it's 2011. I don't know why. Because my intuition says it should be 2012 because we said P naught is 1.14. That means it's for n equals 0. It's the starting one, right? So it should be 2012. Anyway, I'll stick with this 2012. I'll cross-check it because this could be a typo. That is a possibility. So I'd rather say it's 2012. Okay, now look at the entire problem and see if you have any question, because again, I'm repeating myself. It's really, really important to understand what's going on if you want to solve this type of problems.
I have one question, and
Oh.
I'm sure you covered this, but I'm just trying to clarify. How did you go from log of 1.0526 over log of 1.0134 to n equals 3.8512?
Oh, okay, so this 3.8512 is basically this value. If you divide log of 1.0526 by log of 1.0134, you'll get 3.8512.
Okay.
Oh, that's a good question though, because is there anyone who is still kind of confused how to get these values? I mean, how to use the calculator to, how can you use the log function or the exponential to find the nth root? You know, is there anyone who still wants to clarify this thing? because this is really important, because if you can't use the calculator, you'll end up writing this, which might penalize you. If it's a show your question work, then of course I'll give you partial credits. But if it's the online based question in my open math, they might penalize you the entire point from that. So this is really important to know how to get these values, how to use the calculator to get this value. If you're struggling, you can write in the chat section, or we can meet separately, and we can learn how to do this, how to use the calculator properly. Okay. Okay. Any other questions from this problem? If you don't have any other problems, I want you guys to solve a problem now in class now, which I'll do. I'll have the question for you. I'll solve it for you, but I'll not do it myself. You will say, and I'll write one by one. I'll do it step by step. Okay. So I want you to solve exercise. Which one should I go for? Okay, exercise 7. Problem 7 from your exercise. Okay, so exercise 7. So you will say, what should I do? Let's say I am completely new here. I don't know what does this mean. You will let me know and I'll write it down. Okay, step by step. So the first question is, okay, I'll read the question for you first. Tacoma's population in 2000 was about 200,000. Okay, so in 2000, in the year 2000, of course, it was 200,000, the population. Okay, and had been growing by about 9% each year. So the next information we have is 9%. So our problem 7 part A says write a recursive formula for it. Okay, what should I do? How can I write the recursive formula? What does the recursive formula look like? And which model are we considering here? Who wants to go? Who wants to start proceedings?
Real quick, what page is exercise 7 on?
Okay, so exercise 7 is, let me check the page number real quick. So it should be 193, I believe. Yeah, 193. So it's on page 193. What it should be? No one? Just try it. We are trying to see how can we solve it. Obviously, step by step. We don't need to do it straight away. Okay, let me ask from the attendance list. So, okay. Veronica, are you here? Can you hear me? Okay, I don't think she can hear me. Painter, are you here?
Yeah, I'm right here.
Okay, so what do you think the recursive formula should be? The recursive formula for this problem? And why?
I've been having some trouble with recursive formulas, I can't lie.
Okay, no problem. So let me rewrite the recursive in general, the recursive formula, the recursive form rather, for the exponential growth. So if you have an exponential growth, the recursive format looks like this. Okay, the recursive format looks like this, where R is the growth rate, of course. Pn is the population after nth year or at the nth year, depending on the question. And Pn minus 1 is the population the year before. So that's the general format of recursive form. That's the general.
Okay.
Yeah.
So would it be 200,000, I assume, equals 1 plus 0.009? Does it have to be a decimal?
Yeah, that's a very good point again. So R is given in percentage. It has to be in decimal. So if we have R in percentage, we actually need to divide it by 100 and write it in the decimal. So yeah, you're spot on. It should be in decimal. So it should be 1 plus 0.09. And what's your Pn minus 1?
Would it be 200 minus 1?
Sorry, 200 minus 1?
Yeah, right, because that's the population. And would it be the 2,000?
So this 2000 is actually the year where we are considering the population. And this is 200,000. In 2000, this is the population.
Okay, so it would be the 200,000, right?
Okay, so that's the tricky part here. So if it was P naught, we would have straight away written, excuse me, we would have straight away written 200,000 if it was P naught, because it's the starting population, right? But is it P naught? That's the
No,
tricky part. Exactly. So we'll keep it like this because we don't know which n we are looking for. If it is P1, then it might work because then it will become P naught, but it's not. We don't really know which n we are looking for here. So we'll keep it like this. So that's why I picked up this question. So it's not P naught. So we'll keep it Pn minus 1. We can just simplify it just a little bit. 1.10 Pn minus 1. So this will be a recursive form. When you will solve it for, or rather using the recursive form, you will have several informations, more informations to solve it. But this is the format for this question. Does it make sense? Because it's not P naught. You can see that. Everyone, just try to use your imagination here, because this Pn minus 1 doesn't really guarantee you that it's P naught, right? So you can't really straight away write a 200,000 there. If you have to keep it like that. Okay. All right. What's the next question? I think we have 2 more minutes, so we can do just a little bit more. So the next part says write an explicit formula. Yeah, I think we can do up to this and we can start from C the next time we meet on Friday. So what's the explicit formula then? What should be the explicit formula? Anyone?
Would it be Pn equals 1 plus 0.09 to the n and then multiplied by 200,000?
Very good. Yeah. Now once again, I want to show you um, the general format of this, which is, we have already used it, but let me rewrite it for you. It would be 1 plus r to the n times p naught. This time you can see it's p naught. The general format has p naught in it, so you can start with this. And of course our r is 0.09, so we have plugged it in here. So if we simplify it, we'll have 1.09 to the n times 200,000. So this would be the explicit form of this particular problem. Any question up to this? Anyone? Any question? All good? Oh, I can see something in the chat, sorry. So, okay, my microphone isn't working, perfect, no problem. So 200,000 isn't PN? No, 200,000 isn't PN, because if you see the question, let me go back to the question. It says the population in 2000 was, I mean, the year 2000 was 200,000. That means that's the initial population. That's not PN we are looking for. If you go to part C of this question, you can see if this trend continues, what will Tacoma's population be in 2016? In that case, we'll try to find PN. So this 200,000 is basically P naught. Okay, so it's 9:30. I don't want to hold you anymore. So if you have any question, you can send me email. We can look for, yeah, sure, you can leave, definitely. We can look for a schedule that works both for us, and we can have a meeting. And your homework will be available from 10 a.m. I've already posted it, but it will be available from 10 a.m. You'll have 7 days time, and it will be pretty similar to what we have done today. So best of luck for that, and I'll see you on Friday.
Thank you.
Bye-bye.
Thank you.